Good morning, everyone. As of now, only 15 members are joined. We will start our session in a couple of minutes. Meanwhile, if you have any doubts related to our previous sessions and discussions, please bring it on. Are you good with my voice? Am I audible to you?
Yes, sir. Audible.
Yes, brilliant. Right. So last class we discussed about few classes we discussed about what is the purpose of networks and how can we implement those networks in real life, and what are the existing networks and what are the benefits of those existing networks to improve our revenue or credibility or publicity. Many more success rate, many more combinations are there. After that, we discussed about computer networks, a basic definition of computer networks. So apart from that, can we discuss any more up to by the time? And we discussed about what is network plan, what is the importance of information, and how can we achieve the effectiveness of data communications. And could you please anybody tell me that what is network performance criteria? For example, you want to design a best network to improve the performance. What things we need to consider? What parameters we need to consider? You can post in chat box, or you can on your mic, and you can answer my question. How can we calculate or how can we estimate what are the parameters we need to consider to deal with the network performance? Yeah, answer please. I'm expecting some interaction from you guys. Latency, bandwidth. Okay. So rather than those things, number of users, transmission media, hardware and software, perfect. Bandwidth and frequency, excellent. Yeah, good. I'm good for your answers. Very good. So today we will discuss about some other criteria we need to consider. For example, to establish a network, whether that network should be established between only two persons or more than two persons. We will discuss about all those things. Okay. Try to join early because we don't get that much time. Syllabus is very huge here. Are you able to see my screen?
Yes, sir.
Right. So I believe that up to last class we completed up to this point. Yes, sir.
Yes.
Right? Okay. And today we will discuss about some other parameters we need to consider. That is a communication mode. Communication mode means, for example, two devices are communicating with each other by using a link. I mean to say that here we have a device 1 and here we have a device 2. These two are connected with a link. So now if this device 1 and device 2, in how many ways these two devices are communicated with each other? So the mode of transmission, or can we say that there is some different types of communication mode. One is simplex, and second one is half duplex. Third one is duplex or full duplex. So simplex means the transmission of data is started or sending, or the transmission of data is in only one direction. and the other direction, it's not existed. For example, can I say that it is a server and it is a client? In this particular situations, if you want to block something, server can block the client, but the client not possible to block server. Simplex means transmission of data is in only one direction. Half duplex means if these two devices are connected, the data transmission is possible from device 1 to device 2 and also possible from device to device 1, but not simultaneously, but not parallelly, but not at a time, That means first device 1 send a particular message. After receiving a message, it calculating that message and reply back to the question. So you asking question, during asking question, device 2 need to listen. Once he receive all the question and listening is completed, then he reply back to the same channel. And the full duplex means the transmission existing in both devices simultaneously. Both devices are able to communicate with each other. At a time, they can send multiple packets from device 1 to device 2. At the same time, device 2 to device 1 also. That is called full duplex. So here I'm presenting some sample things are here. Just take a look of it. So direction of data is only one direction. Mainframe and monitor. So monitor means it's simply a desktop. Desktop means it is only for displaying some output. There is no reply back, or can I say that remote control. So if you want to switch on the TV, you just click on the remote. That signal is transmitted to remote to television only, but not reverse. Yes or no? Can you tell me any other example of simplex? Any other real-time example? Like remote control.
Keyboard and monitor.
Come again?
Keyboard and monitor.
Yeah, perfect. Keyboard and monitor. So keyboard is a not intelligent device. It's just giving input. So when I type something, that input is transmitted to processor, but not reverse. In the same way, we are calculating something, that calculation is displaying on the monitor, but not reverse communication. Those type of communications are called simplex. So the communication medium is also using simplex mode only. For example, if I'm using this particular writing pad, I have a white here, this transmission medium. I can write something here that is displaying on that thing, but reverse is not possible here. This is one of the example for simplex. Can you tell me any example of half duplex? Half duplex means what? Sending a data from one direction to another direction, and the reverse direction is also possible, but not at a time. Do you have any examples?
So walkie-talkies used by army.
Excellent. Radios, walkie-talkies. So see here, these are some of the points. I believe that I already shared a material to you. You can take a look of it. I don't want to concentrate on more things on this one. These are very basic walkie-talkies. And what is the example of full duplex? Yeah, any real-time example of full duplex. Direction of data all the time.
Smartphone to smartphone.
Yeah, perfect. See here, telephone network. When two people are communicating by telephone line, both can talk and listen at the same time. This is one of the example. But the question is, what is this line? In what way you need to configure it? Line configuration. That means we connected device 1 and device 2 by a single link. So the entire capacity of the link used by these two devices only. If so, then we call this link as dedicated. Dedicated to that two devices only, not possible to share to anybody. Dedicated or point to point, or device to device, or node to node. That's it. For example, if device 1 and device 2 and device 3 and device 4. So this particular link was shared by, this link is shared by device 1, device 2, device 3, device 4. then we call this as a broadcast link. Broadcast, or we can say that multi-point. Multi-point, nothing but multiple systems. So now tell me, in real-time scenarios, where we are using dedicated links, where we are using multi-point links in our real life. Yeah, tell me. In real life, where we are using dedicated links. For example, at the final interview, you need to start an interview process with a particular committee, with a particular interviewer. So at a time, there is only one interviewer and one student. The entire channel or this entire cabin is allocated to those two persons only. Once the interview is completed by the student one, then he will go outside. Then second person will come into the cabin. Yes or no? Yes or no? Yeah, you are not listening to my concepts. So you know all these things. Then I go for the next topic. So all of you familiar with these things? Can I go for the next topic? So all of you busy with doing breakfast. Is it? I'm expecting some reply from you. Okay, then I do my way because I don't want to waste my time. So point-to-point links and broadcast links. So broadcast link means, for example, a single link is shared by device 1 and device 2 and device 3. A single link is shared by device 3 and they connected to server. So here this is called client 1, client 2, client 3. Multiple clients are connected to server. Then how at a time, how these three clients are utilizing this single link. So there are two ways. One is spatially shared and second one is time shared. So time shared means, for example, the capacity of this particular line is 3 Mbps, 3 megabytes per second. This particular link can support 3 megabytes per second. It can transmit 3 megabytes of data. In this particular situation, spatially shared means then I divide this 3 Mbps into 3 individual frequency ranges, 1 Mbps, 1 Mbps, 1 Mbps. The first slot is allocated to client 1. The second slot is allocated to client 2. The third slot is allocated to client 3. So at a time, the channel is dividing into 3 individual frequencies. Frequency 1, frequency 2, frequency 3. Best example is your FM radio. Someone say that 98.5, someone says 96.3. So the name of this channel is different from this channel. Hope you observe this in real time. Yes or no?
Yes.
Right? So they are selecting a particular frequency. If you tune to that particular frequency, you'll get the channel. But that channel does not overlap with other frequencies. In this way, they are dividing multiple frequencies into different parts. At a time, simultaneously, these 3 devices can transmit their individual data to the server. This is called spatially shared, or sometimes we call frequency division multiplexing. Frequency division. And second case, time shared means same concept, device 1, device 2, device 3. These 3 are connected to a single link to the server at this particular time. The capacity of this channel is 3 Mbps. Then I create a time slice or time slot of 30 seconds. So device 1, 0 to 30 seconds. Device 2, 31 to 60 seconds. Device 3, 61 to 90 seconds, and repeat. So for first 30 seconds, the entire 3 Mbps capacity is allocated to device 1 only. Up to by 30 seconds, device 2, device 2 need to wait. And once 30 seconds are completed, then the entire capacity, the entire channel is allocated to D2. Then D2 utilizing this particular channel to transmit his data from 31 to 60 seconds. Once This 60 seconds is completed. This connection will terminate and assign this entire channel to device 3 up to 90 seconds. Once it is completed, round trip time again go to 91 to 120, again 121 to 150, and again 151 to 180. This is repetition up to the completion of sending all their individual messages to the server. Do you understand this?
Yes.
Right. Now, as of now, we discussed about communication modes and line configuration. Now our topic is network models and protocols. So what is a model? Generally, what is sometimes we call it as what is a role model? What is the meaning of this one, role model? Yeah. What is role model? We take as a reference, right? We take it is a standard. We consider it is a path, following path, like these things. In the same way, for effective data communication between multiple devices, what are the individual models we need to follow for effective data communication? Best example is, you know that system or devices understands zeros and ones only. Yes or no? System understands binary language only. But see, when I'm speaking something, my voice is analog. So analog voice is transmitted to my laptop, and from my laptop to my operating system to Zoom application to that Wi-Fi connection to router 1 to router 2, and router 2 to internet service provider in your locator to your Wi-Fi network to your computer to your operating systems to your Zoom link to your earphones. This is the process actually happened. These many involvements are there, and sending a simple message is not easy as you think. Now, when I am sending this analog data to laptop, system doesn't understand this analog voice. It should be converted into digital data, digital voice. The up to laptop to laptop, all the data is in digital format only, digital data. Then here my question is, who will convert my analog voice to digital voice? First question. Right? And who will convert my higher level language to binary language, which will understand by the system? And one more thing, if I'm transmitting 1 GB of data at a time, maybe my network capacity is it can handle only 500 MB. Then my entire 1 GB of data is dividing into multiple blocks. Each block size is 500 MB. So at a time, if a network supports 500 MB only, it can take that only. Just imagine, when you are uploading a particular document in Google Mail or Gmail, it can maximum take 25 MB only through mail. If you want more than 25 MB, you go with the drive. For example, imagine you don't have a drive capacity or drive availability. Then you are dividing this entire task into individual modules. For example, I have 5 module lessons. Each module size is, for example, 500 MB. I want to send 2500 MB at a time, but my system doesn't support it. What can I do? In one mail, I upload module 1 of size 25 MB. Once it is received, I go with the module to 25 MB and module 3, module 4, and so on. Then my question is, who will break your data into blocks or messages? Third question. So do you have any other questions in this conversation? If you interact more, then I'll explain more. Otherwise, I just complete my syllabus. That's it. Do you have any other questions? Other question is, yeah, please. So in this particular context and scenario, do you getting any questions? No. Okay, fine. And I'm having many doubts. So how to identify my source device address? How to identify my network address? How to identify my internet IP? How to identify my MAC address of the source? When I'm sending a message broadcasting, 60 students are hearing my voice, 60 students are listening to my class, then how system identify individual networks, I can say that like this point. So here myself, Pranti, laptop and Zoom. So through this data is transmitted to multiple networks. Here my network is one network, my home network. In this network, how system identify network address? How system identify the process which is working for Zoom? How to identify the process which is working for operating system? And how to convert my analog voice to digital? And how to identify my system address? These are some points. That's okay. Anyways, this is my system I can handle. When I'm sending my voice to student 1, how to identify this network address and student laptop address? And how I'm sending student 2, how to identify this network address, this laptop address? Student 3, network address, this mobile address. Student 4, this network address and this iPhone address. And student 5, this Linux address, network address. So who will take care of all these things? So to address all this issue, I need a reference model. I need a reference. That is called a model. We are applying on the networks. That's why we call it as a network model. Do you understand this?
Yes, sir.
Right. And what is protocol? Do you have any specific definition of protocol related to this context? I'll explain. Protocol means a set of instructions or line-by-line activities to do for data communication via a network. So in this case, what is a protocol? That we need to design a particular protocol that is capable to converting my analog voice to digital voice. But I'm converting this analog to digital voice in Windows 10 operating system, whether the same conversation, the same conversion or transformation is compatible to Linux operating system, whether it is compared to Android operating system, whether it is compatible to Apple operating system. These things will take care by models and protocols. We don't have any bother about all those things. Let us see what is protocols and what is network models here. So basically, our main intention is network models and the related protocols in detail to understand how the data is actually transferred and received at a computer level. For example, when you open a Google, you type something google.com, by default, a protocol is added to google.com. What is that? Let us see. I just open it. I just type google.com, right? So I'm copy this and I'm paste here. What is this? What is www and what is HTTPS? I didn't type that. Yeah. See, actually I'm typing simple thing. I type in google.com only. I am not typing anything. When I press enter, it is showing like that only. But when I copy that and I print here, see here, HTTPS is by default added here. What is this? Hypertext Transmission Protocol, P protocol. So what is the responsibility of the protocol? Connecting web pages and transmitting data securely. If you look into this lock symbol, see here, connection is secure, lock symbol. For example, I open another thing, that is HTTP sites So I go with anything. So I just open this one. Are you able to see this one? It is a warning symbol, not secure. Are you able to see this? So what is this? HTTP means it is not secure. Whatever the passwords or user IDs we are giving, all those passwords and user IDs are still in plain text only while transmission of data. Any third person try to take out the data, then they are easy to identify what is your user ID and what is your password. But in the case of HTTPS, the data should be converted, encrypted into a ciphertext, which is not understood by anybody. Anyways, I will show you by using Wireshark in coming couple of classes. But for time being, I'm explaining these things. See here. So end of the day, protocols decides HTTP for web pages. For example, I want to send a mail. A suitable protocol is SMTP, Simple Mail Transmission Protocol. I want to send a message from one system to another system in the same file transmission protocol. And I want to mapping our IP address with our real-time names or that we are domain name server DNS. DNS means what? System doesn't understand what is google.com. But there should be a mapping with IP address. This map is called DNS, domain name server. DNS will take care about mapping because it is not possible to remember all the IP address by the humans. So we know the high level name, but system doesn't know what is Google is. System only know the IP address. So then to mapping between the IP address and Google, here we are using one map called DNS. It is one type of protocol. Like this way, many protocols are there according to your convenience or according to for your requirement. For network, there are set of protocols. For mail transmission, there are set of protocols. For WhatsApp transmission, there are set of protocols. Many combinations are there. So end of the day, my question is how the data is actually transferred and received at a computer level. Transferred means effective data communication. That should be, the data should be secure. That data should be authenticated. The data should maintain confidentiality. The data should maintain integrity. We need to follow all these things. And end of the day, the intended receiver only receive the data, but not the third-party users. How can we do that one? Basically, we have two types of models: OSI, reference, TCP/IP, and reference. You want to design anything, we can take it as these two are reference books. Best example, when we are opening a syllabus copies, that syllabus copies contain textbooks and reference books. Based upon reference books, you can construct your own data. So what is OSI? OSI means open, S means system, I means interconnection. My first definition, what is interconnection? We already explained this point. What is interconnection? You are again wasting my time, wasting our time. What is interconnection?
Connection between the two parties, we can see.
Yeah, connection between two parts is just a connection. Interconnection means we are able to, yeah, I got some chart here. Two devices connection via a transmission medium. That's okay. That's okay. I use a connection between device 1 and device 2. Just connected. I can say that I can use a current cable here to charge my mobile phones. Is it possible? Yes, it is connected only. I use a current cable or a power cable. I open a power cable and insert into a laptop to a current board. Whether it is charged, right. I use the Nokia 1100 adapter or charger to charge Android phone. Is it possible?
Yes, sir.
Is it possible? Nokia 1100 charger to charge Android phone.
Not possible.
Not possible. There is no productivity. Interconnection means two devices should be connected. This connection is able to transmit data. This connection is able to charge your phone. This connection is able to utilize the purpose. That is interconnection. So, yeah, communication makes exactly correct. So here, open system interconnection. So I need to connect. There should be a meaningful or purposeful data transmission. What is meant by open system? Any to any. Your source device may be iOS device. Your destination device may be Android. Okay, I can establish the connection. I can establish interconnection. Your source system may be Windows 10 and destination may be Android. Yes, okay, interconnection. Any to any, regardless of the type of operating system, regardless of the type of processor, regardless of the type of device, regardless of the type of technology, we will take care about this open system interconnection reference model. It can able to communicate any type of data from any system to any system. Then that's why we call it as open system interconnection. Do you understand this? Do you understand this? Right. In the same way, TCP/IP, transmission control protocol and internet protocol. This is a theoretical approach. This is a practical approach. Now we will look into theoretical approach. According to theoretical approach, we can address practical approach also. Two reference models. We can assume that it is a course, it is a lab, hands-on. Now, so although the protocols associated with the OSI model are rarely used anymore, the model itself is actually quite general, theoretical, and still valid. And the features discussed at each layer are still very important for your purpose. If you want to design a network, what are the things we need to consider? The TCP/IP model is the opposite properties. The model itself is not much used, but the protocols are used. So whatever the protocols we propose in widely used, see, TCP is a practical protocol. IP is a practical protocol. We are all connected to, for example, if you want a command prompt, and I type something, command prompt. See here I have a command ipconfig. See, what is my IP address? Something like 192.168.56. Blah 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 blah. So this is generated by your IP configuration. It is a practical protocol, internet protocol. It is addressed by TCP/IP model only, but theoretically doesn't explain how to define a protocol and how those things are really implemented. Just imagine, I can say that we have a problem, any mathematical problem, without explanation, I just write the answer. Are you satisfied with this one? But some people ask me, sir, I have a doubt in the problem. I just mentioned the answer itself. Are you happy with that?
No, sir.
No, but this answer is given by TCP/IP. But how it happened given by the OSI model. These two are important. How to implement all these things are explained by OSI, but it doesn't address how to get the answer. It just gives the path only, but not the answer. But TCP/IP opposite properties, it directly gives the answer, but it doesn't tell how it happened. How can we implement? Hiding all those details. So anyways, now first question, before we discuss the computer network models, either we count as ISO OSI model, international, this was OSI was developed by this organization, International Standard Organization, and the model name is Open System Interconnection. Now here, let's have a discussion on the layers that a computer model consists. So every model contains some layers. What is the purpose of layers? Any idea? What is the purpose of individual modules? For example, we have a very big task. So is it possible to complete everything by a single person, one person? Maybe if this person handling big task, maybe he will take 100 days. The same big task is assigned to 2 persons, they'll complete 50 days only. If assigned to 3 persons, they'll complete maybe 10 days only. Best example. So here in our second year, we have 2,000 students, and for entire 2,000 students, only one computer network faculty to handle the class. Whether it is a manageable thing, whether it is a comfortable thing. Only one faculty is assigned to 2,000 member students. Can we say that this is effective data communication?
No.
No, sir.
Why? Because, so anyways, I complete my teaching class, and in physical classroom, it is not possible to, there is a no place to sit all 2,000 students at a time. And the same thing, when I'm explaining something, it is not reached to 2,000 students at a time. And next, okay, I complete my class after 60 minutes. And among those 2,000 students, maybe 200 students getting individual doubts. It is not possible to handle these 200 individual students, individual doubts by single faculty. That's why we're dividing these 2,000 students into individual parts and assigning faculty 1, faculty 3, faculty of size 60, 60, 60, and so on. So faculty 1, 60, it is feasible. So here faculty 1, layer 1, faculty 2, layer 2, faculty 3, layer 3, faculty 4, layer 4. So now tell me, what is the purpose of layers? As I explained at the starting of the class, who are converting your analog voice to digital voice? It will take care by layer 1, any layer, and who fragmented or who dividing your entire a big task into individual modules, maybe layer 2. Who will identify your network address? Maybe layer 3. Who will identify your system address? Maybe layer 4. Who will identify your type of operating system, type of network, type of processor? That layer 5. That means each task is divided by individual layers. They do their own task. And if any problem occurs during the addresses of network addresses, then I concern layer 3 only, but not layer 1, layer 2. I don't want to ask anybody. If I'm facing any problem with the processor, I'll ask layer 5 only. If I'm facing any problem for the conversion of analog voice digital voice, I'll take care of layer 1 only. That means there should be a specific point of contact. If any problem occurs, we can reach them. Yes or no?
Yes, sir.
Right? So now read this point. As of now, I explain the things. Now, the same point I explain here, you read this, take a minute of time and read these points. Yeah, to simplify the task and to improve the efficiency. Excellent. It is a very good answer. The main purpose is divide a process of sending and receiving data into small tasks. So sending and receiving, maybe this line is very easy, but implementation is very tough. Very, very tough. So sending from your laptop to cloud, it's a different technology. Laptop to drive, different technology. Laptop to laptop, different technology. Laptop to mobile, different technology. Laptop to pen drive, different technology. It is not compatible. Individual technologies. But who will take care about laptop to, how can we transmit our data from laptop to a mobile phone? You can tell me the practical example. How can we transfer a data from laptop to mobile? Best way possibility. Using Android charger. Yes or no? Yes or no?
Yes, sir.
How can you transfer data laptop to laptop? Yeah, Bluetooth or USB cable. Indirectly, USB cable is nothing but our drive only, our charger only. How to transmit data between laptop to laptop? Share it. Okay, fine. Maybe we can upload the data into cloud and download from the cloud. Even though these two laptops are gone, your data is safe. Because it is a buffer. It can store data, but not share it. Efficient ways. So these are some points. These layers are connected with each other. Each layer provides certain data to its immediate higher and immediate lower. Best example is, for example, I have a head of the department, I myself am a faculty, and my students are the students. Now, whatever the concerns I have students having, as a faculty, my responsibility is I need to give my things to head of the department. What is the status of the students and how they are working on, what are the problems of the students. If you have a problem with the lab allotment, I can discuss with the head of the department. In the same manner, whatever the doubts asked by the students, I am addressing all those things. So here I act as a layer. I can address to upper layers, I can address to lower layers, higher management and lower vendors or customers. So here each layer provides certain data to its immediate higher and immediate lower and receive certain data from the same. So I can receive the data from head of the department to faculty, and I receive the data from timetable actually transmitted from head of the department to faculty. According to timetable only, today I have a class from 9 to 10 for data science students. So without this, I'm not able to get who to take class and what time I need to take class. And dividing a model is layer into layers. That structure quite simple. That makes it easy to identify the issue of the occurs. So issue means what? I explained just now. To handle network addresses, maybe layer 1. To handle physical addresses, layer 2. So if you want any problem to getting the physical address of a particular device, I don't want to go for layer 1. I'll ask L2 only. If I'm facing any problem with the network addresses, then I will ask L1 only. But if there is no layers, everything is combined by a single task, we don't know whom to ask. And our response is very slow if we do not maintain modules. As of now, any doubts?
No, sir.
I'm getting only one response.
No, sir, no doubt.
No, 2 only. So those who are good as of now, please send S message into chat box. Or if you're not able to answer it, you can say no, and you can mention your query also. We will discuss it in separate class. Four, 5, 6. So only 6 members are following my class. So what about others? Eating those are helpless. What this one? There are 3 main components of computer network: model, sender, receiver, and carrier. What is the sender? Just a minute, just a minute. Who is sender? Who is receiver? Who is carrier? In our example, in this class, who is sender? Who is receiver?
Friends with
Enter section DS. Who is carrier?
Two.
So when I am teaching my class, here high level layer is Kranti, medium layer and low layer. But when we have a questions, my class is completed. When we have questions, then data is coming from this side. At this time, this is act as high, this is medium, this is lower. Based on the same example, now look into this theory. At sender side, sender means from Kranti side. For example, higher layer serves the middle layer. Who is middle layer here? Zoom. So I'm explaining something via Zoom. So whatever the data I have, I send it to Zoom. Middle layer directs the message to the middle layer. So anyways, I teach my content to Zoom. What middle layer do? Middle layer picks up the data from the higher layer. Yes, this data is picked up by Zoom and transferred to the lower layer. Who is lower layer here? Section A or data science. Lower layer, the data is transmitted to the lower layer of the receiver side. And at receiver side, what is lower layer? Receive the data from the lower layer of sender side and transfer it to the middle layer. So if you have any doubts, reverse process. Do you understand this? Do you understand this?
Yes.
yes, sir.
Yeah, perfect. Zoom carrier, right? So can take a look of it. This is final thing. Again, we're back to open system interconnection model. It is having 7 layers, each layer having individual tasks. So those 7 layers are here. Application layer. What is the best examples of application layer? I will explain with a scenario. For example, I go with the HTML. I will explain this example, pizza delivery. Are you explaining former classes?
No, sir.
No. So a person, or for example, I will take one. So who is pizza lovers here? Maybe Pranav, or is there? Pranav.
Yes, sir.
Yeah. So Pranav need to order a pizza. Yes, Pranav, what are your list of steps? You can tell me. What is your protocol?
Sir, while ordering pizza from a online
So
portal.
for order pizza, I need application. I go with Zomato. But just imagine, Zomato means Pranav must have a computer or laptop or phone. This should be installed with operating system, either Windows or Linux or iOS or Android. On top of that, there are a list of applications, either Zomato, Swiggy, some other things. Hungerbox. Now he opt a Zomato. Then we have multiple restaurants here. We take restaurant 1 and take an order. This is the process, or is there any other process in general? Ordering online, right? Now he pick up and check out. Then this data is transmitted to restaurant owner. And this Pranav waiting for 5 seconds or 5 minutes and 10 minutes and 20 minutes. Still Pranav doesn't get, or he didn't get that particular pizza. So he called to restaurant or a wallet. Anybody, restaurant. So when he called to restaurants raising a question there. What is the question? In what way Pranav communicate with restaurant people about his status of the pizza delivery? Yes, Pranav, you can tell me.
Sir, in order to check the delivery, sir.
Delivery, okay. Then restaurant owner or particular restaurant person raise a question to Pranav. What is that question? Yeah. Odd, excellent. What is your name, dear? Pranav only. Yeah, right. What, sir? What is your order ID?
Yes.
This is nothing but your binary data. Restaurant doesn't ask about what is your name, what is your girlfriend name, what is your father name. Only thing is what is your order ID. Oh, Srinidhi, sorry. Yeah, thank you, Srinidhi. Good answer. Order ID. So according to order ID, then he tells that, sir, just I hand over this particular thing to wallet. Again, Pranav call to wallet, and now how to identify Pranav to the restaurant. How Pranav call to restaurant? How Pranav reach to restaurant? By using a phone number, right? Yes or no?
Yeah.
This is one of the address. And again, restaurant owner said to Pranav that is hand out to wallet. This wallet details anyway mentioned in Zomato. Again, he called to wallet by using phone number. This is also one of the address. Now, wallet said that, sir, I received a product. I'm on it my way. So wallet or a particular person, that boy starting his journey and reached to how to identify Pranav address. Pranav is in one of the apartment, one of the flat. That flat having some address, flat having some floor. Floor is also some address. Floor is a part of apartment. Apartment have a particular number. Apartment having is at some colony or some street. It is some address. Street in some layout. It is some address. Layout have some colony or some other what we called some housing board. It is some address. So wallet need to identify address 1, address 2, address 3, address 4, address 5, address 6. Up to by this point, he need to follow enter this path. Yes or no? By using either Google Maps. Still, if you have any confusion, you need to take the phone number of Pranav and follow the instructions. So in this particular scenario, the entire task is done by only one person. Only one person. See, for delivering a pizza, how many people are working here? Answer, please. How many people or how many devices or how many routers or how many connections? It is easy as you think. Are you getting my point or not?
Yes, sir.
Right? In the same way, like to identify these individual addresses, we have a different types of models here. Those are this one. You can take a look of it. See here, OSI model stands for Open System Interconnection, you know that. And this model defines how data is transferred from one computer to another computer, you know that. And very basic scenario, two computers are connected with a LAN. Device 1 and device 2 are connected with a local area network that transfer the data. This forms a computer network. However, if the both system uses different operating system, maybe, for example, one system runs on Windows operating system, another runs on Mac operating system, then how can data be transferred between these two different systems, two different processors, two different platforms, two different architectures, two different memory capabilities? Here comes the role of OSI. OSI means open system. Open system means any device we will take care. Which then how can data be transferred between the devices? So OSI model, which is 7-layered model, these 7 layers will take care about how to converting your source dependent format to destination dependent format. You observe that when you open a page in Windows, that page size is very large. When you open the same page into a phone, then this page is converted into the flexible page size of phone only. Do you observe that? Yes, sir.
Yes, sir.
So how can it was happen? The base model is OSI only, Open System Interconnection. On top of that, we have different programming languages, different types of methods and technologies to compress, to expand, to adjust, to flexible everything what you need. But the base model is OSI only, right? So OSI model was introduced by International Standard Organization, ISO. There are 7 layers in OSI model. These are the 7 layers. Application layer, as you said, Zomato. This is one application. Presentation layer, maybe that order ID. And session layer. Session layer means restaurant 1 maybe associating with customer 1, customer 2, customer 3. So this is one session, R1 to C1. This is one session, R2 to C2. This is another session, R1 to C3. But R1 to C1 will take care by this order ID, because how restaurant people identify customer 1 according to order ID only. And transport layer. Transport means how can we identify multiple addresses? How can we deliver these pizzas to different locations? Network layer. How to identify the network address? Maybe street address. Data link layer. How to identify that physical or actually the apartment address? And physical layer, direct handling. Physical means direct pizza. That pizza is hand-to-hand touch it with the from wallet to customer. This is a practical example. We are converting this practical example into our network terminology by tomorrow. Tomorrow we will explain about these individual layers responsibilities. As of now, any doubts? If no, we will wind up the session.
No doubt.
Yeah.
No, sir.
So I request all the students, please put some interest on that one and please be interact. When I ask question, at least say yes or no. If you're not able to answer it, I am not able to get, I lost my interest. Right. Hope we are doing good. It's all at 9:50. Sorry for the delay. Please join early. That's in that way, I'll relieve you as early as possible by 9:50. Thank you all. Bye-bye.
Thank you, sir.
Thank you. Thank you.